Hi everyone. In the given problem statement, you have to solve single number 2. We are given an integer array of num and each element appears thrice except for the one which appears exactly once. Find the single element and return it. So there could be multiple ways of solving the problem, right? So one way could be, right, we can create a hash map and store the, let's say for a key 2, right, how many times 2 is occurring, and it would be a big O of n solution. But because this solution is coming in the bit manipulation, so can we solve it, right, using bit manipulation? So let me show you a way of doing it. And this is going to be a little bit not very intuitive, and it's very difficult to come up with a solution of bit manipulation. So here, right, I am going to convert all the numbers to a 32 sign bits. So here, right, say 2 would be 0032, and at last it would be 1 and 0. Similarly, the other two would be again 1 0. 3 would be 0 0, all the values 1 and 1, and 2 would be 0 0, all the values still 1 0. This is corresponding to 2, 2, 3, and 2. Once you have got it right, so I am going to run a loop for k in range 0 to 32 for all the individual bits. So there is something called an operation called left shift. So I can say temporary value would be 1 left shift to k. So how it is going to work? For the value 0, right? And once that is done, right, I am going to run another for loop. So for each in nums, I am going to say if I can say count once, I am going to check how many 1 bits are present. So the way to check it, right, it would be, right, temp and my current each. So if it's the value is not equal to 0, in that case count once plus equal to 1. So how it's going to work, right? Initially, right, the value is going to shift it to 1 or the 0th position, right? So the kth value or the temp value, right, it would be 0 0 0 32, and the last would be 1. Okay, so I'm going to add it with the 0th bit. So 0 plus 1, right, it's an add operation, so it is going to give me 0. So we are not going to increment the count 1 by 1. I am at this position for this element. I'm working with this one. Again, it would be 0 plus 1 add operation. So nothing is going to get added because if I do an add, it is going to give me 0. Now we are at the third position. So I am going to get here, it would be 1 add 1. So I'm going to get 1, which is not equal to 0. So my current count ones would be 1 now, and then we would be at 0. So 0 add 1 would be 0 itself, nothing changes. So now, right now I have 1 present. Okay. Now I'm going to check if count ones percentage 3 equal to 1, because we know, right, here all the elements are going to appear thrice except for the 1. So here, right, I need to check in case the remainder, right, I need to find out the element or the bit, right, which is not matching or which value is not divisible by 3. So here, right, there would be one element which is not divisible by 3. So in that case, I can say it could be my result would be 0. So initially, right, all the result is 32 bits, right, is 0. So result equal to result and temp. So what is going to do, right? So 0 plus 1. Okay. So 0 plus 1. And it is OR operation, right? Sorry, it would be OR operation. Let me rewrite it. Res equal to res or temp. So 0 would be changed to 1. And this loop is going to end. Now for the k, when it is 1, right? So we would be at this position. So it is at this position. So for each in nums, so if temp, and now, right, temp value would be, I would be converting it to 0. It has been shifted to the first position. So it would be 1 right now. So temp and each, right? So it is 1. So count 1 is going to increase by 1. Same it is going to for this one. Same it is going to happen for this and this. So my current one would be 4. I'm at this position. So count one's percentage, 4 percentage 3 is 1, right? So again, result equal to res plus temp. So this 0 would also get changed or updated to 1. So that's the idea. Once that is done, right, and for all the other one, right, every value would be 0, so nothing is going to change. So nothing got changed or added. So now I got the result. So the result, right, if I convert it to an int, right, it would be 3. But there is one small cache because it's in 32 bit, right? So there is something called unsigned values, signed and unsigned. So basically, right, in the 32, right, so if I counting it from here, let's the first value from the left, right, it is going to have the sign. So 0 basically means if it's positive and 1 means if it's negative. So I can check if result is greater than or equal to 1 to the power 32, or I can say 1 shifted to 32 bit. So if I shift right 1 to 32, right, it would be 1 0 0 0 0 0. So if it's greater than or equal to, so in that case I can do result equal to result, it will be 31. So not 32, it will be 31. So because we are counting from 0, right, so result minus 1 to the shifted to 31, and whatever the value that we're going to get, right, it is going to be our result. It is generally going to require for the time when you're going to calculate for the negative numbers. So that is the idea. So I know there would be a lot of things to cover in this entire single number and bit manipulation. So, and it is not going to be very, very intuitive. I would suggest you, right, go through the solution, try to understand, right, why each and every line has been written, and try to redraw or sketch up, right, how this every code is going to function, and then you're going to come up with the solution. So now let me jump to the Python solution, and I think once with the Python solution, a lot of things are going to get even more clearer. So let me create the variable result, which is going to be 0, and for every bit, right, because a 32 bit, so for each, right, so for k in range 0 to 32, and I'm going to have the temp, which is going to have 1, which is going to get shifted by left shifted by k bits. Now for num in nums, if temp and num not equal to 0, so I can have a variable called count once, which is going to be 0. So count once plus equal to 1. Now I'm going to check if count once percentage 3 equal to 1. In that case, I can say this is our unique element, right? So I'm going to add it to the result. So to do that, right, I'm going to use an OR operation. So result or temp, and I can return the result. Let me run it up. As you could see, it is running successfully for the public test cases. Let me do it for the submit it up. And as you could see, I'm getting an error. So when the expected is -4, right, I'm getting a big value. So the reason it is happening, right, because I have not handled the cases of unsigned values. So if my result is greater than or equal to 1 left shifted by 32, so in that case the result is going to be result minus 1 shifted to 32. And now if I run it back again, the public test case is passed. Let me submit it. As you could see, it got submitted successfully. So that's all for this video. See you in the next one.